Folks, so we're going to take a look at number 3 from the puck packet. It says, while resting on the floor, the puck experiences a constant push to the right. But I thought we could take a quick look at the video that supports this one, which looks like this. And one more time. Notice that the puck was speeding up while moving to the right. So, what did the puck do? Oh, I want to say from rest, actually. From rest, speeding up to the right. So what forces were acting on it while it was speeding up, moving to the right? Well, was there still gravity pulling down on it? You betcha.
Attention students, and a friendly reminder to staff. Students, tomorrow, 9th grade students will be taking the TSAT 9 in the World Language Wing. This will also include Mr. Aiello's class and Mr. Holscher's class. This wing will be closed to all students and staff. Students, if you have anything in your locker,
The force of push on the puck by the air.
please go before the day is over to grab your things from the World Language.
If we add up the upward force plus the downward force, they would balance each other out. What would be left over? The force of push on the puck by the air,
Expect that wing to be back open to students
which would be
and
the net
staff
force.
approximately 12:30.
Motion map.
Thank you for your support.
From rest, it speeds up while moving to the right. So we get no velocity vector on the first dot, a short velocity vector, a longer velocity vector, and a longer. Notice that I made no velocity vector, a 1 hash mark velocity vector, a 2 hash mark, and then a 3 hash mark. And if this thing's speeding up in a positive direction, is it accelerating? You betcha. Which way? In a positive direction. So all these acceleration vectors should be the same length, and we'll put a single hash mark on each. Speeding up while moving to the right while experiencing a net force to the right. We're going to do one more of these before we wrap this up. This problem says the puck is already moving to the right while experiencing a constant force to the right. What will it do? It will also speed up, but not from rest, speeding up while moving to the right. So what forces are acting on this? We still have gravity, force of gravity on the puck by the earth. We got force normal on the puck by the air, which would have to be exactly the same size. And we still have the air hitting it from the side from the leaf blower. That'd be a force of push on the puck by the air. And when taking a look at all 3 of these forces, the vertical forces would cancel each other out. So when looking at the net force, it would be the force of push on the puck by the air to the right. And in this case, I'm going to leave a bigger distance between the dots initially because it was already moving to the right when it began to speed up. And so we get a velocity vector on the first one, and even longer and longer and longer velocity vectors, and our acceleration would be positive as well in the same direction. Next up, we'll have to consider what happens to an object when it's moving to the right but experiencing a constant force to the left. Check out the next video to do number 6.